Hello everyone, my name is Suraj Jagtap, Assistant Professor, RMD Sinhgad School of Engineering, Varje, Pune. Welcome to the session from the subject Foundation Engineering, in which we are going to cover unit number 5, B part, which consists of Foundation on Black Cotton Soil. Now when it comes to black cotton soil, we consider black cotton soil as the worst soil on which a construction can be done. This is only because of the physical properties which black cotton soil exhibits under its dry as well as in its wet condition. So starting with the foundation on black cotton soil part, expansive soils are those soil which swells considerably on absorption of water and shrinks on removal of water. So there is a massive change in its volume as the water content changes. The expansive soil has considerable strength in dry state, but the strength goes on reducing on absorption of water. The soil exerts considerable pressure on foundation during swelling. This soil poses major foundation problems, causing damage to the superstructure if proper precautions have not been taken. The expansive soils, with their expanding lattice structure and resulting capacity for wide ranges in water content, can be particularly troublesome. Settlement due to shrinkage and heave due to swelling causes structural instability. This problem is magnified in hydraulic structures. The amount of volume change in expansive soil is related to initial dry density and water content, amount of clay fraction and type of clay minerals. Characteristics of shrinkage and swelling due to moisture movement, hence dangerous. Shrinkage cracks formed is also known as tension cracks. If swelling is checked or restricted, high swelling pressure acting in the upward direction will be induced, results in several cracks in structures. These soils have very poor bearing capacity ranging from 5 to 10 tons per meter square. So this was a brief introduction to black cotton soil and the properties which are exhibited by those soils and the adverse effect or the negative impact of those properties on the structural behavior and the stability of the structure. Now there are some tricks or tools by means of which we can identify which type of soil or whether a site consists of black cotton soil. The first one, the capacity of a soil to swell depends upon the type, amount of clay minerals and exchangeable bases. So there are three groups of mineral which are listed, and for identification of expansive soil, different field and laboratory methods are available, in which different terminologies are also being used, which will be discussed in further times. In practical conditions, the expansive soil in field can be identified by the cracking pattern of the soil in summer. As in summer, the water content is reduced and the soil becomes dry, some cracking patterns can be seen on the surface of the soil, by means of which we can distinguish whether the particular soil is an expansive soil or the black cotton soil or not. The laboratory identification test can be grouped under simple test. So when we are talking about simple laboratory test, of term known as free swell test or the free swelling is important. Now in this free swell test, this test is performed by slowly pouring 10 cc of oven dry soil passing 4 to 5 micron sieve in a graduated 100 ml cylinder filled with distilled water. The volume of settled and swelled soil is read after 24 hours from the graduations of the cylinder, and the percentage of the free swell is calculated by the following formula. So the result of this formula gives us the coefficient for free swell test. Now depending upon the criteria of free swell test, we are having a differential free swell test, which is a modification of the free swell test which we have seen earlier, and this differential free swell test gives us a coefficient known as DFS coefficient from the DFS test. In this method, two samples of oven dry soil passing 4 to 5 micron sieve and weighing 10 gram each are used. Whereas in case of free soil test, only one sample was used. In this case, we are having two samples. One sample is poured slowly in 50 ml graduated glass cylinder filled with kerosene, and the other sample is poured in other 50 ml graduated cylinder filled with distilled water, as in case of free soil test. Both the cylinders are left for 24 hours and the respective volumes are noted, and the coefficient for DFS is calculated by the following formula. The degree of expansiveness of soil and consequent damage to the structure with light loading may be quantitatively judged as described below. So depending upon the DFS value, which is the differential swell test, the value, if it is less than 20%, then we can say that the degree of expansiveness is low, or else we can term it as a soil which can be treated and which can be used for further construction. But if it ranges from 20 to 35%, the degree of expansiveness is moderate, and for 35 to 50 or greater than 50, it can be termed as high, which needs certain treatments or a specialized type of foundation which is to be used in this case of expansiveness soil. Some of the engineering properties which can be a major troublesome issue in construction of foundation in expansive soil are: the first one is the theories of swelling. It is common observation that when swelling soil comes in contact with water, the volume of soil increases, and this phenomenon is known as swelling. Now this is to be measured, means when the swelling is done or when the swelling is appeared in the soil, it exerts a swelling pressure from the beneath of the foundation. So measurement of this swelling pressure is important. When an expansive soil attracts and accumulates water, a pressure known as swelling or expansion pressure builds up in the soil and is exerted on the overlying material and structure if there are any. Now this swelling pressure is defined as, in a common term, if a swelling substance is tightly enclosed in a vessel with a wall permeable to a swelling solvent and latter is allowed to diffuse into the vessel, the dilation tendency is nothing but the change in volume tendency of the soil solvent gel gives rise to a pressure called as swelling pressure. The two commonly used methods for measuring the swelling pressure are constant volume method and constant pressure method. Now there are many of the methods which can be used for calculation of or measurement of swelling pressure, but in here we are discussing only of these two, which is constant volume and pressure method. Now coming up to the measurement of swelling pressure using constant volume method. In this, the soil is mixed with appropriate quantity of water. After maturing period, the soil is placed in the mold. The bulk density and water content of the specimen is determined by standard methods. The specimen is covered with porous stone and filter paper. The entire mold is placed in a watertight under loading machine through proving rings and dial gauge to measure force and swelling of soil. The expansion of soil per specimen is nullified by applying force gradually, and proving ring readings is recorded at different time intervals till there is no further swelling of soil. Pressure intensity is calculated from proving ring readings and specimen area. A pressure versus time graph is plotted. The maximum pressure intensity gives the swelling pressure of soil for a specific dry density and water content, which was earlier tested for the specimen which was used under testing. The following shows the instrumentation used for this constant value method. Coming up to the constant pressure method. In this method, minimum 3 identical soil samples are subjected to 3 different load intensities and allowed to saturate and swell or consolidate. The load intensities are so selected that soil swells under lowest load intensities and consolidate under maximum load intensities. After the equilibrium is achieved, the changes in the volume of specimen are recorded. A graph between load intensity as abscissa and volume change as ordinate. The load intensity at which volume change is 0 is termed as swelling pressure. Now here are some of the engineering problems when we are going for construction in black cotton soil. The first one is the deep excavation for foundation, which is to be done in case of black cotton soil to find out the hard strata for firm base for foundation. Black cotton soil are residual soils resulting from weathering of igneous rock. This thickness of soil stratum can be high as 3 to 10 meters. Laying the foundation on a firm, non-swelling stratum involves deep excavation in stiff clay and increase the cost of construction. So this was the first engineering problem which we are coming across while construction in black cotton soil. Second is the assumption of low bearing capacity. The correct estimation of allowable bearing capacity of black cotton soil is complicated by various factors such as the swelling pressure, groundwater table variation, site condition and so on. This leads to assumption of lower bearing capacity. But if the probable swelling is higher than the assumed bearing capacity, the foundations are subjected differential settlements. Cracking of single-storied building is very common than that of double-storied building in case of differential settlements. Coming on to the next problem, non-uniform swelling or shrinkage. The equilibrium water content is not same below the foundation. This leads to differential settlements and diagonal cracks of masonry superstructure. And the next one is the high cost and low reliability of rehabilitation. Remedial measures for damaged structures are costlier and not reliable in long term. Hence, prevention is better than cure. So these are some of the engineering problems which we are facing while construction in black cotton soil. So to avoid those problems, the construction techniques for foundation in expansive soil are as listed. The first one is the removal of entire expansive soil. The first and very simple method is to remove the entire layer of expansive soil up to the firm and non-expansive strata. But this is only applicable when the depth of expansive soil available is to that extent which can be removed, or if the depth of expansive soil is greater, then it can increase the cost of the project. The second is to provide a cushioning layer between bottom of the foundation and top of the soil. The cushioning layer is a granular soil to allow the swelling of soil to penetrate its voids. So in case of expansive soil, the cushioning layer which we are providing between the bottom of the foundation and the top of the soil is nothing but the sand. So sand can provide us the mode void ratio in which we can sustain the swelling of the soil, and the differential settlement which is occurring due to the swelling of the soil can be reduced. A raft or mat is a combined footing that covers the entire area beneath the structure and supports all the walls and columns. This type is used when the allowable soil pressure is low and building loads are heavy. And the last one is the use of deep piles, piers and underrim foundation, the knowledge of which the deep foundation and the piers have been explained in the previous units, and underrim piles will be discussed in later times. Coming on to the underrim pile foundation. Now when we are talking about the underrim pile foundation, it is nothing but a method to increase the bearing capacity of the soil or to sustain the loading in case of black cotton soil. So in both ways we can consider the underrim pile. The best method of foundation in expansive soil is foundation which is anchored at the stable zone of the ground in which the moisture variations are negligible. This was observed from the performance of cast-in situ piles with enlarged bases, and which is termed as underrim pile. The pile having one bulb at the base is known as single underrim pile. The load bearing capacity of pile can be increased by increasing the number of bulbs at the base. The diameter of the underrim piles varies from 20 cm to 50 cm, and the bulb diameter varies from 2 to 3 times the diameter of the pile. So here is the graphical representation of single underrim pile, in which we are having the pile which is known as the stem, the diameter of which can be considered as d, and if we are providing a underrim or the bulb, the diameter of that bulb du should be at least 2 or 2.5 times the diameter of the stem. So this is all about the single underrim pile, and when we are coming up to the multiple or the double underrim pile, the same terminology is used, where d is nothing but the diameter of the stem and du is nothing but the diameter of the bulb, which should be in the range of 2 to 2.5 times the diameter of the stem, and the spacing, the vertical spacing between the two bulb, center to center spacing, should be at least 1.25 to 1.5 times the diameter of the bulb, and the vertical length of the bulb is 1.5 times the diameter of the stem. So this is all about the double underrim pile geometry, and the working or the function of underrim pile can be as the bearing capacity, which will be at the toe and as well as on the circumference of the bulb. So this additional bearing, which will be sustained by the surface of the bulb, can increase the maximum load sustained capacity of the pile. So it is stated as, if the bulb are more in number, then the more times we can sustain the external loading, or we can apply the load on the pile. Important note about the underrim pile are as below, which consist of the physical and as well as load carrying capacities, important assumption or the important geometrical parameters. By providing underrim bulb, the ultimate load capacities of the piles can be increased significantly. The ultimate load bearing capacities of the underrim pile with angle of underrim bulb of 45 degrees and 0 are almost same. There 3 or more underrim bulbs are advantageous only when the spacing ratio, which is s by du, is 2 or less, and when s by du, that is the spacing ratio, is greater than 2. Multi-underrim piles do not have specific advantage. The ultimate load bearing capacity of piles are maximum when the spacing between the two underrim bulb is 2.5 times the diameter of the underrim bulb, which we have discussed earlier. It appears that the spacing between the two underrim bulbs suggested in IS is 1.25 to 1.5 times and is not the optimum. The expression suggested by the IS can be used for predicting the ultimate load carrying capacity of underrim pile with the spacing ratio s by d is equal to 2.5. Now coming on to the bearing capacity of the underrim pile, it can be calculated as that of the same concept which was used in calculating the ultimate bearing capacity of a single pile, wherein the ultimate bearing capacity of underrim pile can be calculated by the addition of the resistance offered by the tip and the resistance offered due to the skin friction or the skin resistance. So here are some expressions which can be used or which can be referred in case of calculation of bearing capacity of underrim pile in place for single as well as for single pile in toe resistance and in skin resistance, taking into consideration that the soil in which we are calculating the ultimate bearing capacity of the underrim pile is a clayey soil. So this was all about a brief summary of foundation in black cotton soil, the errors which are occurring, the terminologies which we can help, and the method by which we can construct the foundation. Any issue in this regards can be posted below. And last one is the method of construction of underrim pile. It is same as that of a single pile which can be driven into the ground. The only difference is that we are having a bulb over here, and in case of pile it is a single pile with constant diameter. So the equipment for the construction of pipe consists of auger boring guide, spiral auger with extension rod, and under reamer with bucket and concreting funnel, etc. So in this method of construction of under rim pipe, only the under reamer with bucket is the extra factor which makes it a difference under a simple pipe and a under rim pipe. The auger should be rotated slowly with a constant downward pressure and taken out with it is full with soil when it is full with soil. The holes for casting pipe in the ground may be bored by using hand auger as well. For deeper boring, the length of the auger can be increased by adding suitable extension rod or pipes. In sites where the subsoil water table is high, bentonite slurry are used to retain the sides of the borehole against collapse. For extra information, bentonite slurry is also used in tunneling for finish work of a tunnel. After the pile holes are ready for concreting, the reinforcement cage are lowered in the hole and concreting is poured by using the funnel. So this was all about the construction method used for under rim pile, which is similar to that of a construction of simple pile, but in which under rimmer with bucket makes a major difference. So this was all about the foundation in black cotton soil. Any issue in this regard, or if you think that some of the points are missing in this video, or if you have any suggestion to make this video a better one, please post, and for clearing out the doubts you can be in contact, or you can post your queries down. Thank you.